And it says an electric quadrupole consists of two electric dipoles in such a way that they are almost but not quite cancel each other out. Calculate the V for points on the axis of this quadrupole. How will we do that? So say at point P. What will V1 be? What will V2 be? What will V3 be? Given KQ over R minus D. Correct me if I mess up. So far, so good? Taking common out, KQ, 1 over R minus D, minus 2 over R, plus 1 over R plus D. Taking the LCM, KQ, R plus D, minus 2, R minus D, R plus D, plus R minus D, divided by R minus D, R plus D. Opening brackets and simplifying, I'll have R squared plus RD minus 2R squared minus 2D squared plus R squared minus RD divided by R squared minus D squared. Please make sure I don't mess up. So that means this will go away. This will go away. And I will be left with KQ 2D squared over as always, do I know that R will be always much, much, much greater than D? So may I rewrite this as 2K Q D squared R cubed 1 minus D over R squared? Using binomial expansion, can I write this as KQ D squared divided by R cubed? If D is smaller than R, 1 minus a very, very tiny number is almost equal to 1. Like that's what we know, right? Give me a thumbs up, right? That makes sense? Okay, excellent. So then may I rewrite this V as 2KQ D squared over R cubed for a quadrupole. RU, right? Quadrupole, quad or a quadrupole. So summarizing, anyone remember for a point chart? For a point charge, V varied as, anyone remember? 1 over R. For a dipole, V varied as, and for a quadrupole, woohoo! Do you remember when we did the same thing for electric field? Also went the same way. It was R squared. Then for a dipole, it was R cubed. And then for a quadrupole, it was R4. Yeah. The more number of charges, the more it changes.